Hello, Math 1340, Statistics. This is Professor Wenson, and in this video I'm going to go through the KnewtonAlta homework for section 1.1, which is titled The Definition of Statistics, Probability, and Key Terms. Alright, so first I'm going to show you where to find it. Now I'm on Math 1340 R1602. If you're in any section of my Math 1340, you're looking at the same stuff. Now I'm not in student view right here. I'm in my view, the teacher view. But the modules are pretty similar, right? I mean, this is week 0. Here's week 1. And to get into an assignment, you can get into an assignment in many ways. And this will be the only time I really show you this, because it's the first time. You can either click on the assignments tab and find the assignment you're looking for, or as the weeks open up, I'll have pages for each assignment you're supposed to be doing. So I'm starting here in section 1.1. Click on that, and then a page pops up where I say, okay, here's what you should do in relation to this particular section. I would recommend you read the section related to this material in the OpenStax book. Okay, and I do have a link to that section in OpenStax. You just click on the link in the page and it takes you to the section 1.1 in your OpenStax statistics book. There it is, 1.1. And here it is, right? And then the science of statistics deals with the collection, analysis, interpretation, and presentation of data. We see and use data in our everyday lives. Now, I'm not going to read the section for you, right? But just notice how it's like any other textbook. There's bold words, right? Pay attention to the bold words, read definitions, key terms, just read through it, read the examples, and try to figure out the solutions to the examples before you click on show solution, just to see if you're getting the material. And then some try-its, I would recommend doing those as well. Again, here's an example. Again, I would please try to do it before, based on what you've read. Use what you've read to try to do the example correctly before you see the solution. There's another example, and there you go. And most of these in the first chapter are pretty short. All right, but now you could also, I'll get to the homework in a second. And beneath all the homeworks, I also have watch, where I've, here are just some videos I found on. Again, some objectives have one video, some have multiple videos that I've found on YouTube related to the objective. And these are videos made by other people besides myself. If you'd like to see more, just search for the objective on Google or YouTube. Just highlight the objective title or type in something that's similar sounding to it in YouTube in the search bar and hit enter, and lots of related videos should come up. But what I've done is I've put here a video. Now you can try playing it in Canvas. See the play button here? It doesn't always work so hot. So I would just say click on the link. There should be a link to the YouTube video, and here it is, right? A YouTube video on the one. There's only one objective. I'm gonna exit out of that though, because I don't want to watch it. You can watch it. But I'll have objective, and there's only one objective in section 1.1. Every homework, every section here is going to have from 1 to 6 objectives, depending on the size of the section and the material in it. And it's understand the definitions of population, sampling, statistic, parameter, and data. Alright, so let's get into the heart of the video, right, what this is really all about, and what my videos for you will be on is how to work through, watching me work through a KnewtonAlta assignment. Now the KnewtonAlta problems, the questions, change from person to person. The numbers change, the wording changes sometimes. So what I am seeing is not going to be exactly what you see. It'll be very, very similar. Like there'll be the same kinds of problems, and the way I'm going to do them is going to be the same way you should be doing them as well. But just don't copy down what I'm doing and write exactly what my answers are on your homework, because you might be seeing a different question in a different order than I'm seeing. All right, I'm just giving you a guide, right, and going through the material. So there should be a big link with bigger font for the KnewtonAlta homework. So I click on that and it takes me to a page here. Now you'll probably be seeing it in student view just in Canvas, or you'll have a button that says load in another tab or launch in a new tab like I have here. Right. Now again, when I do this, I'm a teacher, right? I'm in the teacher view right now. So you're not going to see what I see. All right, but I will show you what the assignment looks like as a student. So I'm going to go up here to options and preview as student. All right, so here's what you'll be seeing when you're into section 1.1 or any of the KnewtonAlta assignments. So you have the section title up top. You won't see the word preview. This is just for me. I'm previewing it. But you'll see this empty mastery bar up here. This just shows you how far along in the assignment you've gotten. And again, the more you get correct, the higher, the quicker that bar will fill up. If you get problems wrong, it might back up a bit. So don't guess on answers too often. It's better to click on more instruction and work through the supplemental problems than it is to guess something wrong and have it take you a lot longer time, because the more you get wrong, the more problems it will throw at you, and it'll take longer to fill this mastery bar. Now, once the mastery bar has reached 100%, then you'll see that grade show up in Canvas. All right. If it's under 100%, you won't see the grade in Canvas until Monday, May 10th, when it's due. All right, at 11:59 p.m. So if you want to make sure you're getting, if you get through 70% of it and you're happy with that, you won't see the grade in Canvas until the very end of the semester when it's due, but it will come up as a 70%. All right, just keep that in mind. All right, now I'm on a question, and you see up top here it'll say current objective. Now, as I said a second ago, there's only one objective in this section. It's understand the definitions of population, sampling, statistic, parameter, and data. And you see the little, it's pretty faint, but there's like a circle with a star in it. This is like the mastery bar for that objective. So this circle will fill up as you complete more questions related to this objective. And then once you've done enough of them correctly, it'll fill up, and then you'll see the star fill in. And if you want to see all the objectives in the section, you click on this down button here. And as I mentioned, there's only the one objective. All right. And it even gives you an estimated number of questions. See, you can have anywhere from 4 questions to a bunch, right? If again, the only way you're going to get a lot is if you just keep answering things incorrectly. It'll keep throwing more problems at you. So again, don't guess. Try to get things correct the first time around, and not just guess on things, so that the assignment will take less time. All right. So my recommendation to you is, if you've read the KnewtonAlta section, if you read the OpenStax, right? If you read the OpenStax section 1.1 and you're comfortable, you feel like you've got a grasp on the material, then I would just start answering questions. All right, but here's another way you can go through the assignment pretty well. I would recommend that every time you see a new objective, which, this is the first time I'm seeing this objective, the first question with this objective, I would recommend, now you are not going to have the instructor cheat button, all right? This will not be there for you. Now there is a feedback button that you'll have that if you see something wrong with the question, you can tell Newton about it, or something wrong with the answer. I've done this many times over the past year. But you're going to have this More Instruction button. And when you click on More Instruction, it takes you to some material. And most of that material is taken directly from OpenStax. All right, so here's what I'm going to do. All right. I'm going to say, hey, this is a new objective. I've never seen this objective before. So I'm going to click on More Instruction. And then, View Instruction. And here we go. And then, like I said, a lot of these definitions, basically, the people at Newton have kind of taken the OpenStax material and either copied it in here or summarized it and kind of shortened it. So I already read that sentence to you, right? Remember this sentence I read at the beginning of 1.1 here, the science of statistics, blah, 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 right? So we got some definitions, right? We want to study a population. A population is a total collection of persons, things, or objects under study. So everything we wish to study. Gathering information on a population often costs too much or is virtually impossible. Instead, we collect a sample of the population, right, which is a smaller portion of the larger population, right, just a smaller collection. This is usually easy to do, and a sample should have the same characteristics as the population it is representing, right? So it should have a kind of a similar makeup to the population you're trying to study. Data are information about populations or samples. Generally, there are unknown characteristics or variables about a population that we wish to know, like like if I went around to every single student at Macomb and I wanted to I recorded everyone's height and weight. Right? The height would be a variable, something that varies, something that changes from person to person. The weight would be a variable, something that varies, variable, right? Something that changes from person to person. And something that I record can record about each individual in my sample. Data may be numbers, which is quantitative data, or they may be words like labels or qualities, qualitative data. Once collected, the data are used as the actual values of the variables, right? So like I was saying earlier, if I'm recording the height is the variable, and then, 6'3", 5'4", 5'7", those numbers are the data, right, related to that variable. All right, so I'll read through an example. Now, I'm not going to do this with every single video. I'm just doing this. This is the first video here where I'm showing you how to go through a KnewtonAlta assignment. So example 1. You want to determine the overall grade point average at your school. There are 1,800 students at your school. Since you want to collect data about all of the students, all 1,800 students is the population, right? Everyone you're trying to study. The variable is the GPA, right? That unknown, right? That thing you want to determine, right? So you would go to every single student if you could and record what's your GPA, what's your GPA, what's your GPA, and so on, and record all these GPAs, and that gives you a set of data. But the GPA, the thing you're recording, the unknown, that changes from person to person, is your variable. But It would be difficult to ask every single one of the 1,800 students in your school about his or her GPA. So, it would make sense to gain information from a smaller group of students who attend your school. So, you survey 200 random students, right? This would be a sample of the population, right? This portion of the population is called a sample, the 200 random students. Then the grade point averages of these 200 students surveyed is the data, right? So it's like 3.5, 3.9, 2.2, 2.0, 1.7, right? All those numbers that I record, all the GPAs, are the data that is collected. And some other definitions here. A statistic and a parameter are both descriptions of groups, but they represent different groups. A parameter is a number that is a property of the population. Right? Now, I think it's easy to remember this is because they both start with P, parameter, population. Okay. So the overall GPA of all 1,800 students would be a parameter. Sometimes when the population is small enough, there is no need to take a sample because you can talk to everybody. And so determining a parameter is easier and more accurate reflection of the population. A statistic is a number that represents a property of the sample. Again, easy to remember, I feel, because they both start with the same letter. A parameter describes a population. A statistic represents a property of a sample, right? Parameter, population, statistic, sample. The statistic is an estimate of a parameter, right? Because you're trying to estimate the population's overall GPA, but you only have 200 students, right? So an example here would be, the overall GPA, the average GPA of these 200 students would be a statistic, right? Because it's something representing the sample, not the population. All right, so here's another example. There are 100 senators in the U.S. Senate. 20 senators voted against a bill last month. This number 100 is an example of a parameter because it is a number that represents the whole population, right? If our population is all of the U.S. Senate, then 100 is a parameter. It describes an aspect of the whole population. That's everyone, 100 people. Next part. There are 12,000 people at a football stadium. You want to determine the average number of miles people drove to the stadium. Instead of surveying the whole population of the 12,000 people, you randomly choose 1,000 of those people as your sample. The average number of miles driven to the stadium by the 1,000 people, by the sample, is an example of a statistic. Right? So just pay attention to whether or not the number you're looking at describes an aspect of the whole population or it describes an aspect of the sample. And then you got usually some highlights here, key terms, right? I already went over these: population, sample, variable, data, parameter, statistic. All right, so I'm done looking through the more instruction, which again I recommend you look at anytime you get a new objective, or if you're stuck, if you're struggling. Like I said earlier, don't guess. If you're struggling on a problem, click on more instruction. And then when you're done reading through it and maybe taking notes, and there's some of them have videos too, hit continue and it'll throw a problem at you, a question related to that objective. And you can still see the instruction up here if you want to go back and review. All right, that's the nice thing about this. More instruction stuff. All right, so the question is, you want to find the average test score of students in every math class in 11th grade. There are 15 math classes in 11th grade. You survey the scores of 7 of those math classes, and you calculate the average test score is 83%. So let's run through this, all right? And I'll speak out loud here. This average test score, right? The test score is the variable, right? Because that would change from class to class. You know, what's the average test score in the first class? 75. What's the average test score of students in the second class? 59. In the third class, 92, right? That's your variable, right? And then the actual scores themselves, right? Like the 59, the 75, the 82, whatever I said, those numbers would be the data. Now, these 15 math classes, right? That's all the math classes in 11th grade, and that's what you're trying to study, all the math classes in 11th grade. So these 15 math classes are the population, right? And the number 15 would be a parameter, right? It's a number describing the population in some way. The average test score of every math class, all 15, would be a parameter, right? Anything related to all 15 math classes would be a parameter. But you don't look at all 15. You survey the scores of only 7 of the math classes. So this is a sample, right? It's a portion of the population. And you calculate the average test score for this sample is 83%, right? If you looked at all 7 of these classes and averaged their test scores, you get an average of 83%. Now this number is related to the sample, so that means this number is a statistic. Okay? So the question is, which of the following represent the sample and the parameter in this scenario? Right. Now, the sample is clearly these 7 math classes, so it's either one of the first two, right? This is a multiple choice. Now, you could say 15 was a parameter, but that's really there's nothing else to say. All 15 math classes are there. Cool. There's no other number, though, that describes the population. This 83% is a statistic, right? I mentioned the 83%, this average test score, is for the 7 math classes, not all 15. So see number 2 here, the second choice, where it says the parameter is the average test score of 83%, that's wrong. That would be a statistic. So it's the first one, right? The sample is the 7 math classes. And there is no parameter, again, other than, just the number of people in the population isn't really much of a parameter. It's just, but like the average test score for the entire population, that would be something I'd want to know. So here there is no parameter described to us in this scenario. And then I'll hit submit. And it says, yes, that's right, keep it up. It gives you encouragement, right? And even when you're wrong, it'll say like, that's how we learn, or whatever, right? It tells you some words of encouragement. And then even beneath, now the answer explanations usually are more in depth, but this is a multiple choice one, so not much of an answer explanation. Great. So then I hit continue, and it throws another question at me. And again, that instruction's still there. All right? It gives you a few until it feels like you've got the material down, and then it takes you out of the instruction. And this is also going to count towards my mastery. All right? When I get these questions and the more instruction correct, it will count towards my mastery of the topic. So question. There are 6,000 people who attended a political debate at a convention center. There are 3 candidates who are participating in this debate. Mr. Smith, Mr. Jones, or Miss Roberts. You want to find out which candidate is most popular amongst the people attending. You ask 500 people as they walk into the convention center. All right, which represents the population in this scenario? Well, you're trying to see, which candidate is most popular among the people attending. So you'd be asking, if you could, you'd be asking for information from everyone attending this debate. So all 6,000 people who attended this debate is the population. The 500 people you actually talk to would be a sample. And then the variable is, what candidate they prefer, right? Because that's going to change from person to person. Who do you prefer? Who do you prefer? Who do you prefer? And then the number of people that prefer Mr. Smith in the 500 people, right? Again, if you're talking about these 500 people, would be a statistic. The number of people who prefer Mr. Jones in this 500 people would be a statistic. The number of people who prefer Miss Roberts in this 500 people would be a statistic. Now, if you were talking about the 6,000 people, then they would be parameters, right? The number of people who prefer Mr. Smith of all the 6,000 people, that would be a parameter, because we're talking about the population. But the population in this scenario is all the people attending the debate. I submit. It says, great work, that's correct. Again, if it's wrong, you'll see the answer and continue on. Alright, so now I'm done. Now see how it took me out of the more instruction. Took me out of it because it said, hey, you got a couple right. Feels like you don't need the instruction up there anymore. Let's try it without the instruction. Okay, so same objectives, see? And look, now the mastery is about halfway done. Same thing here for the mastery bar. It's 45% finished. Alright, it's 45% done. So let's continue on. Now it's again the same objective. Sharon wants to estimate the percentage of parents that use cloth diapers. She asks a randomly selected group of 75 parents whether or not they use cloth diapers. What is the population? Parents. Right? She takes a group of 75 parents out of all parents. Right? The 75 parents is a sample. All parents, right? She wants to estimate the percentage of all parents who use cloth diapers. So it's just all parents is the population here. Correct. I hope that makes sense. Continue. Look, now I'm 75% done. Looks like I only got one more question to get. Annie wants to estimate the percentage of homeowners. This is pretty much the same thing as the parents. Now, like I said before, you may see different questions than I'm seeing. All right, you might see different questions than I'm seeing. But I'm trying to just give you a guide through these KnewtonAlta assignments. All right. So Annie wants to estimate the percentage of homeowners that own at least one dog. She surveys 75 randomly selected individuals to determine whether or not they own dogs. Now here again, they're asking what is the population, right? Like I said, you might see something different. They might ask, what is the sample? What is a parameter? What is the statistic? Okay, what is the variable? What would be the data? All right, they might ask questions like that. And if you're struggling, either go back to the OpenStax book, or I would recommend you click on, whenever you're struggling or whenever you see a new objective, click on more instruction. Read over that again. Maybe even go back and watch the video I posted for you from YouTube, or search for other videos. Like, there's lots of stuff you can do. Read the OpenStax, do more instruction, watch YouTube videos. There's lots of stuff you can do to help you when you're struggling. And if you've done all that and you're still having problems, maybe take a screenshot of the question right? Take a screenshot of the question and email it to me. Send me a message in Canvas with that attached, and tell me what your problem is, right? Explain to me, hey, I'm having a problem with this. But again, only after you've exhausted all of the resources. You've read the OpenStacks, you've done more instruction, you've looked at YouTube videos, you've taken notes, if you're still having problems, let me know. Okay, last one. So this one, was the population. Her sample was 75 selected individuals that are homeowners, right? Because what she's trying to study, Annie's trying to study the number of homeowners that own at least one dog. So she wouldn't want to look at people that don't own homes, right? She wants to look at homeowners to see how many of them have at least one dog. So all homeowners. And she only takes 75 of them, right? The sample would be 75. Now that percentage that own at least one dog, the percentage of the 75 homeowners that own at least one dog would be a statistic. The percentage of all homeowners that own at least one dog, that number, that percentage would be a parameter. And then this number of dogs owned would be the variable. Right? The thing that she's recording here would be number of dogs. You own 0 dogs. This house owns 5 dogs, 7 dogs, 2 dogs. Right? What you're recording, what you're trying to what you're recording from your sample, from your population, whatever you're asking, is your variable, right? The thing that can change from individual to individual. And the data, right? If they asked about the data, it would just be the numbers of dogs in each house. Right? The actual numbers, 0 dogs here, 2 dogs there, 5 dogs there, whatever. Those numbers of dogs would be the data. But they only ask for the population, right? It's all homeowners. Submit. Great answer, explanation, cool. And again, the little population is the entire group of individuals being studied. In this, there is an explanation there. I continue, and oh look, assignment previous complete. But I hope you saw that real flash by real quick. But when the objective was completed, that circle filled in with a star, and the mastery bar was full because there was only the one objective. All right, so there, I'm done there. So I hope this was informative. I hope this helps you. And I'm not going to go as in depth as I did in this video in future videos, but I will still do the more instruction, but I'm not going to read every little thing to you. I'm going to leave that to you. But I will highlight the important stuff, and I'll go through I'll do this with every single assignment you have this semester. All right. Thank you very much for watching, and I hope you have a pretty easy time getting used to the KnewtonAlta.